All right, so here is your review for unit 5. So we're going to use for number 1, A, B, and C, these two functions here. Which function do you start with for A? You're going to do f of 8. All right, this is like your quiz 2.0. All right, so you're going to do f of 8. Here we go. 8 squared. That's 64 minus 3 times 8 is 24. You can do that in your head. You don't have to write it. I just, note to self. I just jotted it down. Now, what would that give you? 40. And you're going to pass that along to function g. So we're going to do g of 40. So now we're plugging 40 in right here. Negative 40 or negative 4 times 40 would be negative 160 plus 5 would be negative 155. Did you follow me there? Yeah. Math and stuff. All right. Now these two will not have a numeric answer. Why not? Because there's no number in it. I'm going to need you to focus way more than you are right now. Okay. So for this one, G gets plugged into F. That means this whole thing, the negative 4x plus 5 gets plugged in over here. I'm just going to try and write really small and see if I can get it to fit. So it's going to be negative 4x plus 5 squared, but I would just write that twice. And then minus 3 times negative 4x plus 5. From there, it's not difficult. It's just tedious. It's just a lot of distributing. But the numbers in the this is my pep talk. The numbers in the problem are 3, 4, and 5. Can you multiply 3, 4, and 5 together and like add and stuff? Yeah, so you'll be fine, all right? Negative 4x times negative 4x. That'll be 16x squared. The outsides would give you negative 20x. The insides would give you negative 20x. So together, negative 40x, and then 5 times 5 is 25. And then when you distribute the negative 3, that will give you plus 12x minus 15. And then you just put the like terms together. Again, don't factor it when you get to the end. I'm not testing you on factoring. That's not what this test is on. So don't do that. Just whatever you get is whatever you get. So 16x squared. We got negative 40 plus 12. That would be negative 28x. And then 25 minus 15 is 10. So that's our final answer. Now, usually one way is kind of complicated, and then the other way is sort of easy. When you do G of F, this time all of this is getting plugged in over here. So you're going to have negative 4 times all of the other function plus 5. And there's really only one thing you have to do with that, which is distribute the negative 4. So it will be negative 4x squared plus 12x plus 5. Now, when you have a graph or a table like these next few, these are no work questions. You should be able to fly through them and just get the answer, all right? But listen, write the middle step, because if you look at it wrong and your answer's wrong, I can't do any partial credit. So write me the middle step. And I don't have a better answer than, hey, look. So you're going to have to look up here and watch me point to it. F of G of 0. You're going to start with G and do G of 0. Watch. Here's 0. Where does that hit the graph? 0 what? 2. Do you see how it's 2? I don't have a better reason than, hey, look, it's 2. All right. So you plug that into function F, and please write that, F of 2. That's the middle step I was talking about, because like if your answer's wrong, I can't do any partial credit. And then you look at function F, that parabola, and you find the point 2 comma whatever. What does that give you? Do you see it right there? And I can't explain it any better than, hey, look. All right, so negative 2 is your final answer. All right, let's try it again. G of negative 1. Well, start with G of negative 1. What does that give you? 0. So you're going to pass that along, do G of 0. We actually already looked at that one. G of 0 is 2. Good. All right, and then which function do you start with for that C one? Start with F. Find F of 4. You want the point 4 comma whatever. What is F of 4 going to give us? 2. Good. Right there. So when you pass that along, now you're doing g of 2. So you want the point 2 comma whatever on function g. So that would be 2, 6. Do you see that right there? 2, 6. All right, so 6 is your final answer. Table is the exact same thing, but it's even easier. You just have to be able to read the table, all right? So you would start with the inside function, start with g. What does g of 4 give you? Just match up g and 4. 3, do you see that there? G of 4 gives you 3. You pass that along, then you're going to do f of 3. So match up f and 3. -2 is your answer. I really like the table ones. I think those are easy. All right, and then this one, you're going to start with f. What does f of 1 give you from the table? 3. Plug that into g. G of 3 is 0. All right, 4 is where you're separating them apart again. I think it's easier to do g of x first. That's the insides. G is like the guts of the problem. So what is g going to be for part A? X cubed plus 10. And then the outside function that you're plugging that into is 5th root of x. So you're just separating it apart. So you have the answer you're looking for the question. What would g, the inside function, be for part B? Yeah, the 5x plus 1, good. And then the function you're plugging that into, yep, perfect. Kind of like those two. You're just separating it apart. All right, this section is like your quiz 2.0. Do all the simple domains first. And if you can't get this stuff, it's not a very large portion of the test, okay? Who's your troublemaker for number 5 for F? 6. Skip over 6, kick him out. He's a troublemaker. All right, and then for G, it shifted left 1. So it's going to be bracket -1 to infinity. And I'm going to skip that other stuff for right now. I'll come back and answer it, but let's just do the rest of it. What is going to be your domain for 6 for f of x? Yes, ma'am. Perfect. Went left 3. And then this one, if you graphed it, it would be a parabola. So all reals. Good. Number 7, same thing. That one that has a squared, that's all reals. If it's a quadratic or a line or an absolute value, it's going to be all reals. And then this one went right 8. So 8 to infinity. I always say I'm not going to put an 8 and an infinity in the same problem because it looks weird, but then I always forget and I stick that in there. So it looks like the 8 got tired and fell over. All right, now let's go back and answer these. All right, but if you can't get it, don't freak out because it's not like it's not a large part of the test. All right, so for all of them, I did f of g. So g gets plugged into f. That's going to be 1 over square root of x plus 1 and then -6. You can't do anything there. We don't want to lose any more butterflies. All right. One of the numbers is inside the square root, one is outside. So just leave it alone. All right, now the domain. You ready? Does G have a restriction? What does that mean you do with it? Keep it. And if you feel like you're going to get stuck with the next step, just copy that over and I'll give you half a point. Do you know what I mean? Like I'll give you half of it. All right. You're going to keep that. So hold that in your mind. Does F have a restriction? That's where you set up a problem. Hey, G of X, you better not what? You better not equal 6 or else. All right. So we're going to do like a little margin problem. I'm going to try and set this up over here. We're going to take G of X, this square root of X plus 1, and then say, hey, you better not equal 6. So what symbol is it? Not equal to 6. And then you just work that out. You don't try to force it to be anything. You just see what happens. What would you do to start solving that? Good. Square it. 6 squared, I knew what you meant, is 36. And then what would your last step be? -1. So X cannot be 35. So you want to skip over 35, like with the unions, but you also need to remember to keep this restriction. You want to be -1 and above, but also skip over 35. So it's going to look like this. arguably the hardest problem on the entire thing. Because they both had a restriction. But I believe in you. I don't think it was too bad. All right. G gets plugged into F. That is going to give you square root of x squared minus 7 plus 3. Now, can you go another step or stop there? Yeah, why can we combine them? They're like the same, like they're both underneath. They're in the same place, so you can put them together. Now, if one's underneath and one's not, then you can't do that. All right. Does G have a restriction?
No.
Does G have a restriction? No. Hallelujah. Does F have a restriction? Okay. Hey, G of X, you better do what? You have to stay bigger than -3 or else no desserts. Okay. So let me find a spot over here. We're going to take G of X, this x squared minus 7. I'm just going to do this down in the corner. You'll have more room on your test. I just wanted to fit this on one piece of paper to save trees. Okay. We're going to take our G of X, our x squared minus 7. You better stay bigger than -3. So what symbol? Oh my gosh. Yes. Perfect. And then you just see what happens. You don't try to force it to be anything. What would you do next? Like with plus 7? That'll give you 4. And then, now your square root of 4 is 2 and -2. Do you remember the little alien antenna ones? Do you remember these? You're all staring at me blankly. Do you remember me drawing these? Because I think that they're super cute. It would look like this. There were even some of these in the Delta math. Remember that? Okay, cool. Thank you. How do you write it then? It would be -infinity to where? Good. Bracket union. Well, we already did the -2, so the other one's going to be 2 to infinity. So you want -infinity to -2, union 2 to infinity. You can always draw a little sketch of it to help you. Yeah. This one right here. So you need to stay bigger than -3, greater than or equal to -3. If you use the not equal to, you're simply leaving out -3. We want to stay bigger than, we want all the numbers bigger than -3. That's like you have to be this tall to ride the ride, this much or more. Okay. All right. Last one of these. We're going to take G, plug it into F. That is going to be 1/2. I'm going to write down here because there's going to be a couple steps. 1/2. And then you're going to have this whole thing, square root x minus 8 squared minus 5. The reason there's a couple steps there, not a whole ton of work, but what is going to cancel out? Yeah, good. Your squared and square root are going to cancel. You would distribute the 1/2 through there. That'll give you 1/2 x minus what? What would half of 8? Good. And then the -4 and -5. Yeah, minus not. Good, perfect. You can keep going there because the whole thing canceled. And then this is the easiest one. You ready? Does G have a restriction?
Yes.
What? It is just, well, okay, good. You're correct, but let me get everybody there. You're going to keep this. I don't have to set up a problem because why? This one's all real. So this is just your answer. Just copy it over. Okay. I'm sorry, I can't give you a break. This is usually where you get the halfway through break, but your break was the 2 hours you got this morning. All right. So given F and G, show that they are inverses using composition. Please listen to me because this is really commonly missed and it's a direction following thing. I make it worth, like, I think 4 points on the test because it's a lot of steps and it says show all steps. So it's worth a lot of points. If you don't do composition, I can't do any partial credit, like none. I will have to write -4. Now, you guys know I start grading as you turn them in. So I try to catch it and give it back to people like, here, you didn't follow directions. I can't catch them all though. So you need to know what composition means. That means F of G and G of F, okay? And you have to label them because they're different. So we're gonna do F of G and then we're gonna do G of F. So when you do f of g, this whole thing gets plugged in over here. Now, spoiler alert, it's all going to cancel. But you have to show me the order. The order is what's important, okay? You're going to have 2, and then all of that other function, cube root of all that stuff, cubed minus 9. It looks like a great big mess, and it's all going to cancel, but the order is what's important. That's like the thing you're learning. So what's going to cancel first, the 2s, the 3s, or the 9s? 3s, good. The cubed and the cube root cancel first. Then you have to write the next step. But Ms. Cole, I don't want to. Well, didn't I relate it to a paycheck? You want a paycheck, you have to do work. You want the points, you have to write it out, okay? It'll be 2 times everything that's left minus 9. Because if you just put a bunch of big slashes on your paper, like my telepathy is not working, and I won't know what order you canceled them. So what's next, the 2s or the 9s? The 2s are next. That gives you x plus 9 minus 9. And then they cancel and you get x. You will get x. Spoiler alert. Like that's the answer. You will get that. You're showing me the order of the steps. That's the important thing. All right, I wrote that one up there, said have space. I'm going to put the other one down here. That was f of g. Now we're going to do g of f. And yeah, you have to write that as well. I take off a half a point if you don't label them. I have to know which one's which because they're different. So now g gets plugged into f. And you're going to need to draw a gigantic cube root with everything shoved in underneath. So I'm going to put this whole function right there where x is. So 2x cubed minus 9 plus 9 over 2. It's going to cancel in the opposite order of the one we just did. They should go in the opposite orders of each other. Does that make sense? Okay. So like, do you see how this one was the 3s and then the 2s and then the 9s? So what's going to cancel first in this one? Yeah, the 9s. So you have cube root of what's left. And then what? The 2s, good. So you have cube root of x cubed. And so the 3s cancel and you just get x. I'm not going to do b. It's the same thing except different functions. All right, you're showing the order in which they all cancel. Oh, crud. I forgot I needed to graph this. So I am going to need to like write this on a separate thing. If you want to just watch, you can. On the test, you're going to have a grid. Okay. So we're going to find the inverse and then we're going to graph them both over here. Oftentimes I suggest that you graph them first. So actually maybe I'll do that. I forgot I had to make a grid. I'm sorry. Bummer. All right, I'll label them with colors, even though it won't show up real great. Let's plug in some numbers. What do you want to try and plug in? What's probably the easiest thing to plug into this? Because I know it looks like a complete disaster. 1 or 0. Actually, those are the first 2 I'm going to do. So if you plug in 0, 0 to the 5th. Good job. 0 times 5, 0. Good job. You guys are good at this. Plus 6. 6 divided by 2 is 3. So 0, 3. You're right there. And then let's try 1. 1 to the 5th. 1 times 5. 5 plus 6. 11 divided by 2. Now that will be a decimal. It's 5.5. So we get 1 5.5. So like right about there. All right, I need one more point though. What do you want to try? We did 0 and we did 1. What else do you think would be good? Negative. Let's do, good choice. Good choice. Let's do -1. You guys ready? Shh. -1 to the 5th. Okay, that means -1 times -1 times -1 5 times. Okay, that would be -1 times 5, -5 plus 6. 1 divided by 2 is 1/2. So -1, 1/2. Now it's going to look like a line. You just need to know that it wiggles. And that's because it's to the 5th. When you go to do the inverse graph, all you're gonna do is take those points. You know, today's weird. I know we had a delay. But I'm gonna hand you a test. Trying as hard as I can to get all this in. Okay, you're gonna take those points and flip them. Okay, so instead of 0, 3, 3, 0. Weren't you guys the ones that said converse, not inverse? Like it's converse. Like you just switch them, all right? Instead of 1, 5.5, you're gonna have 5.51 be right about there. And then you would have 0.5, -1. So like right about there. And again, you just need to know that it wiggles. Oh, and do you guys remember what line I can dot in to check the, yeah, y equals x is gonna be right there. You can see the reflection. All right, on the test, you'll have a grid. I'm sorry. I was trying to fit this onto one piece of paper so that I could save trees, okay? I'll put this on here when I take the picture of it and post it. You know I put everything on Schoology. It's all there for you. All right, then you're going to go back and actually do the problem. When you switch x and y, it will be x equals what? 5y, good, plus 6 over 2. And then you just undo all those steps. It's the order that's important. What would you do to both sides? Start to try to get y by itself. Times 2, good. You guys are good at this. This is like, I feel like the easier part. Although graphing's not hard either, just make a table. Plug in 0 and 1, like those are the easy numbers. All right, then what? Yeah, -6. Then what? I feel like my question is always then what? Like divide by 5, so you're gonna have 2x minus 6 divided by 5 equals y to the 5th. And then 5th root, good. Were you guys the ones that said square root 5 or something like that? Or somebody said that, I don't know, maybe it was a math. Anyway, it's called a 5th root. I'm not gonna yank you in the hall and make you take a verbal exam, so. And then I will mark it correct if you put y, but I will be happier in my soul if you put inverse because that's what we found. I'm going to do 11 next to review how you split these. Do you remember how a parabola has an axis of symmetry straight down the middle? Okay, you find where that center is and you can either do the positive half or the negative half. You don't need any part of this except the x minus 5. You can like scribble out the rest of it. You don't need it. What direction did it shift? Left 5. So your center is at where? -5. With me still? -5 is the center. So you can either do everything to the left of -5, negative infinity to -5, or what's the other option? Yeah, good. -5 to infinity. So you split it at -5. Extension question. Say it went right 7. What would the two options be? Negative infinity to 7 or 7 to infinity. Just split it at 7. Do you see what I'm saying? Wherever the center is. Okay. So for this one, do you see how I picked the negative half? I'm going to force you to do the -1 on one of them. And that means when you do a square root, you're going to put negative. Don't put plus and minus. You're making a decision. You're only going to do the negative. Now I would do the domain and range first. Do you see plus anything out here? No. So if it didn't move up or down, it's still centered at 0. And so your range is 0 to infinity. And then what do you do to get this domain and range? Switch them. Switch them. That's it. Just recopy them, but the other way around. And then when we do this problem, when you eventually do a square root, you're going to do the negative square root because I forced you to do the negative half. Okay? So scribble out f of x, call it y. We're going to switch x and y. So it'll look like that. I feel like these are the ones you guys are real good at. It's the one I made you turn in work for. It's that assignment. What would you do first to get rid of the 1/3? Oh, you can't distribute in there because of the square. Good. Multiply by 3. So it'll be 3x equals y minus 4 squared. Yeah, you can't distribute if there's a power on that, unfortunately. Square root. And again, it will be the negative square root. Don't put plus and minus, just making a choice. And then the last step, plus 4. And I even wrote F inverse on the paper and left you a blank to put it on. So you can't even miss putting inverse because I printed it on the paper. I'm going to be able to finish this. Perfect. We're going to get through the whole thing. All right. Number 12, restrict the domain. Hey, kiddos, if I give you a choice, pick the positive half. Yes? Pick the positive half. Where is the center of this? You only really need to look at that part. Where's the center? 3. So you would want to make your domain 3 and everything above. Pick the positive half. It got split at 3. Pick the positive half. And then you're going to switch X and Y. And when you eventually have to do a square root, you're going to do what? The positive one. And you don't have to put a plus, just don't put a plus minus. Just it's the positive one. You're making a decision. It's one or the other. All right, what would you do first there? There's actually 4 steps. This one's kind of a lot. You got to get them in the right order. Get plus 8. And then I think what you said is next. What did you say over here? Times by 2 to get rid of the 1/2. You don't have to distribute the 2. You can if you want to. It would be 2x plus 16, but you can leave it right like that. And then what next? Get square root. And don't put a plus minus. You just want the positive half. And then your last step, plus 3. And I even left you a little blank to put it on. Yes, I put one on here like 13. If you just listen to me, you're going to get it right because it's a definition. And we actually already brought it up. What line do inverses reflect over? And here's an example of it. See that? Reflection. All right. How can you determine if a function is 1-to-1 from looking at its graph? Do you remember what line test it was? Horizontal line test, which is the exact same thing as the vertical line test, except with a horizontal line. If it hits more than once, it fails. Now, if you don't have a graph to look at, you look for the even powers. If there's an even power, it fails. Okay? So when you look at A here, what do you think? Yes or no? Yes, it's good. It passes. How about a square root? A square root would look like this. Like visually, that's what that graph would look like. Yes, that's good. And then how about this one? Why not? It's got a squared. It'll fail horizontal line test. All right, and then last one, that's what we did last time, is your difference quotient. I view it as steps. That formula is long, it's difficult to memorize. So step 1 is you're going to plug in x plus h. So it's 3 and then x plus h squared, but just write it twice, minus x plus h plus 4. That's step 1. Plug in x plus h. Does anyone remember step 2? And this is the thing that makes stuff cancel. You do what with the whole thing? Good. Minus the function. Do you remember playing the relay game? What was the third step? We are going to do that. The third step, it's all over h. I'm not going to write that here for the purposes of having space, okay? So this is going to be 3x times x. Good. You have xh on the outside, xh on the inside. So that would be 2xh, and then h times h. Good. I'm going to go ahead and just distribute that. That would give you 3x squared plus what? 6xh plus 3h squared. Good. I didn't want to have to write the whole thing over again. I'm trying to save you some writing. All right, what would the next part be? You'd have to distribute this negative sign. So what would that give us? Perfect. Perfect. And then plus 4. This is about staying organized. I've met people who are brilliant, geniuses, and can't do this because they can't stay organized. You have to stay organized. All right, and then distribute this negative. That's going to give you minus 3x squared plus x minus 4. Now that should all be over h. I just, ran out of them. Okay. If you have done your job correctly, what should happen at this point? Stuff should cancel out. Like most of it should go away. So do you see something that's going to go away? All right, the 3x squareds are gone. The minus x and the plus x, good. And then the 4s. How many terms are left? 3. And what do they all have? H. So you factor it out. When you factor out the h, you'd be left with 6x and then what? Plus 3h. This is really tricky. Good. Minus 1. And if you weren't writing over h, there's where you bring it back. And the reason why is those cancel. And then this is your final answer.